Joint implementation is defined in Article 6 of the Kyoto Protocol. This mechanism allows a developed country to carry out emission reduction or removal enhancement projects in other developed countries. The implementing country can earn emission reduction units or ERUs, each equivalent to 1 ton of carbon dioxide, which can be counted towards meeting its Kyoto target. A GI project must provide a reduction in emissions by sources or an enhancement of removals by sinks that is additional to what would have otherwise occurred. This is an important eligibility criteria. Projects must have approval of the host party and participants have to be authorized to participate. Joint implementation offers parties a flexible and cost-efficient means of fulfilling a part of their Kyoto commitments, while the host party benefits from foreign investment and technology transfer. A project hosted in Czech Republic by Denmark aims to reduce the level of nitrous oxide emissions in the country's largest fertilizer manufacturer. The greenhouse gas nitrous oxide is a byproduct of the production of nitric acid, an essential component of fertilizer. This project comprises the installation of a new catalyst technology in the existing installation for the reduction of nitrous oxide emissions. ERUs were expected to be more than 1 million tons carbon dioxide equivalents between 2008 and 2012. Based on the Joint Implementation Project Agreement, the project will use the additional funds from selling the ERUs it generates for green investments, which will lead to positive environmental impacts of operations in the town, like the rehabilitation of brownfields and optimization of the wastewater treatment plant. The next project is hosted in Romania by Denmark, and it seeks to improve the environmental conditions in 5 towns in central Romania through fuel switching in the district heating systems. The project reduces the environmental impact of dumping waste sawdust and wooden chips in forests and other natural areas. The project puts this waste biomass to use, turning it into fuel that powers 5 new boiler plants. The heat and hot water are then distributed to residents of the towns via a new network of pipes installed as part of the project. The sawdust substitutes for natural gas, oil, and coal that were previously being used in the district heating systems. Growing the oilseed plants for the biodiesel will also revive the cultivation of traditional vegetables which had been planted in the area in the past.